Welcome back to the Mechanics of Solids lecture series. We're working on internal shear and moment functions in beams. In this video we'll start a new example with a cantilever beam as shown here. This is a problem from Mechanics of Materials by Timothy Philpott, Wiley 3rd edition. This cantilever beam has the fixed support at the right end, has a concentrated moment of 120 kip feet at the left end, and a distributed load of 5 kips per feet acting over part of the beam. We're to find the reactions, the internal shear and moment functions, and draw shear force and bending moment diagrams. We'll start out by finding the reactions. I'll replace the fixed support at the right end with an unknown reaction C sub y in the y direction and a reaction or a moment M sub c drawn in the positive direction. Notice I'm not going to include a reaction C sub x in this case because I can see that it will be trivially equal to 0. Okay, the working units for this problem are kips and feet. I'll evaluate C sub y by summing the forces in the y direction equal to 0. Assume positive going upward. I have C sub y minus the contribution due to the distributed load, which is 5 kips per feet, times the distance, 6 feet. The feet cancel out, set that equal to 0, and C sub y equals 5 times 6, or 30 kips. To find the concentrated or the reaction moment M sub c, I'm going to sum moments about point C, set it equal to 0, and take it positive in the counterclockwise direction. Now about point C we have 3 contributions to the moment. We have M sub c, which is in the positive direction. We have the concentrated moment at the left end, and this is just a moment, not multiplied by any distance. It's acting, as I have them drawn, it's acting in the same direction, the counterclockwise direction. So it's also going to be positive, 120 kip feet. And finally we have the moment due to the distributed load. Now you may have been taught to replace the distributed load by a resultant force of 30 kips in the center and with an effective lever arm of 3 feet. This is okay, but it's important to be careful when you do this. Recognize it is actually a distributed load and not a concentrated load, because you can get in trouble when you're drawing shear and bending moment diagrams if you replace the distributed load by a concentrated load. So I actually like to do this instead of replacing it by a concentrated load. I recognize that this distributed load creates a moment about point C equal to the value of the load, distributed load, 5 kips per feet, times the distance, 6 feet. That's where we get the 30 kips. And then the lever arm is half of that distance, or 6 over 2. So I would just replace this 6 feet squared and then divide by 2. So notice the moment is equal to the load times the distance squared divided by a factor of 2. Set that equal to 0, and we solve for M sub c equals negative 120 kip feet minus 5 times 6 squared over 2, which computes to 90. One of these feet cancel out, so the distance is also kip feet. And the sum of those two is equal to negative 210 kip feet, where the negative sign tells me that the reaction moment is in the opposite direction of what I assumed it to be. We'll continue this in the next video.